All right, welcome to your trigonomic functions introductions. The trigonomics is all about triangles, and trig helps us find angles, distances, and is used a lot in science, engineering, video games, and more. So we're going to be reintroduced to SOHCAHTOA, which you may have heard in 8th grade or 6th grade or even younger. SOHCAHTOA is only relevant to right triangles. So SOHCAHTOA is SOHCAHTOA, and they'll all mean something once you see the connection. So trigonometry is mainly about right triangles. For this right triangle right here, we're going to start by labeling our sides based on our current angle. So the current angle that we're looking from is angle theta. This is theta. So we're going to label all the other sides based on the position of theta. So the first label that we have, which is consistent regardless of where you're looking at from, is the hypotenuse. The hypotenuse is going to be the longest side, and it's always going to be opposite of the right angle. All right, after hypotenuse, we have two other sides. We have the adjacent side, which is the side next to angle theta. Right here is angle theta. The side that's adjacent, which is right next to angle theta, is either going to be this one or this one, but we've already labeled this as hypotenuse. So this can't be hypotenuse and adjacent. This can only be hypotenuse, which makes this one, the side next to angle theta, adjacent. Right, so this side is going to be opposite of adjacent of theta. And then the last side that we have is the side that is opposite of angle theta. So this one is going to be opposite. And it's opposite of theta. Adjacent to theta. You don't need to write the of theta and to theta, but that's just because we're introducing it to you for the first time. You do need to know that it's referenced off of angle theta. So we're starting off with the first one, sine. Say this with me, not sin, but sine. If I hear you say sin, it's because I know you didn't listen to the audio. This is sine. Sine is going to be a ratio for angle theta that compares the two sides. So sine is going to be opposite over hypotenuse. Oh, can't spell. Let's just go hype. Sine is going to be opposite over hypotenuse. Cosine right here, not cosine, cosine is going to be adjacent over hypotenuse. Then the last one is tangent. Tangent is opposite over adjacent. Right, and again, these are all ratios. These ratio represents the relationship between the two sides. All right, let's start off with example 1. Example 1, identify the following trig ratios in a simplified fraction form and decimal form. Okay, so we're going to need a calculator. We're going to do some decimal forms. So let's start off with sine of A. So let's look at angle A right now. I wouldn't recommend you do this in probably two different colors, because you will have to use two reference points. So first, we're going to go down. We're going to go A, 1, 2, 3 first. So starting off with sine of A. So let's start labeling for A. This one's going to be hypotenuse. Let's start this one as black. Let's go from A. This one's going to be adjacent. Let's do this one as red. And then from A, the side opposite of angle A is going to be 3. So this is going to be op. This is your op. All right, so we're going to find sine of A. Not sin, sine of A. So we go back up here and we look at sine. Sine of an angle is equal to the opposite side over your hypotenuse. So going down here, opposite is going to be 3 over your hypotenuse is going to be 5. which is 0.6. All right, cosine of A. So now cosine, oh yeah, maybe I should write that. This is going to be op over hype. Cosine of A is going to be adjacent over hype, which is going to be 4 over 5, which is going to be 0.8. And then tangent I'm going to look up here is opposite over adjacent. So op over adjacent, and that's going to give me 3 over 4, which is 0.75. Okay, so far so good, right? We're going back to reference what the formula is for sine, for cosine, for tangent, and because we labeled everything already, we're just picking it from here, and then we're putting it to its appropriate spot, right? So now for sine of B, since we're looking at the same triangle, it's going to be a little bit confusing, but I am going to do this in blue. So blue, because now we switched position, and we're looking at it from B, the adjacent is no longer 4, because this is now adjacent to B. And then this is no longer, 4 is no longer the adjacent side, 4 is now the opposite side, because it's opposite of B. Alright, so maybe if that's confusing, I would definitely mark this off. That way we don't get confused as to which one's which. But the hypotenuse is still the same. So we look at the hypotenuse as right here. Hold on, dropped my pen. The hypotenuse as right here, and it's still the same whether we're looking from A or from B. All right, so let's go through sine of B. So sine, try to recall it, opposite over hypotenuse, which is 4 over 5, which is 0.8. Cosine is adjacent over hypotenuse, which is 3 over 5, which is 0.6. And last one, tangent is opposite over adjacent. And this is going to be equal to 4 over 3, which is 1.333. Right, so notice that even though this one asked for sine, this one also asked for sine, because this one asked for sine A and this one asked for sine B, you have two different answers. So now here's a pattern that I'll challenge you to find. Within all 6, which 2, I guess there's 2 pairs, which 2 are equal? And do you see why they're equal? That's going to be for you to ponder on and for you to think about. Because as soon as you recognize that pattern, that's going to make your life a lot easier.